Hello, and welcome to our presentation of the Thin Hull Air Taxi. My name is Jordan Reingrover, and I'm here with Tatum Hardy, Alex Day, Alex Kay, and Alex High. The Thin Hull Air Taxi is a propeller-driven aircraft that seats 6 passengers, destined for the business jet market. Face-to-face connection continues to be a driving force in an ever-changing business world, and the Thin Hull Air Taxi will ensure customers are able to pivot at a moment's notice. With lower operating costs, shorter runway requirements, and ample cruise range, this aircraft is able to transport its passengers exactly where they need to go without the cost and performance prohibitions of a standard business jet. This provides a summary of the aircraft's performance for its fully sized mission. This aircraft is designed to require only one pilot to carry its full capacity payload of 6 passengers, corresponding to a 5,010-pound takeoff weight. The climb section is completed at a rate of 800 feet per minute, and the cruise section is designed for a cruise velocity of 190 knots, approximately 218 miles per hour. It is worth noting that the Thin Hull Air Taxi aircraft also has an economic mission that is expected to be carried out most often. This economic mission only changes by changing the payload from 6 passengers to 3 passengers, and will be discussed further in this presentation. When constructing the payload range curve for the Thin Hull Air Taxi, there were 4 key points to consider. Point A describes the payload capabilities of the aircraft with a 0-mile range. This payload remains constant until we reach the mission cruise range of 345 miles at point B. After point B, the payload begins to decline with added range. With a full fuel capacity of 1,000 pounds, our aircraft can carry approximately 810 pounds of payload 900 miles, which translates to 4 passengers flying from Atlanta to LaGuardia in New York with 130 miles to spare. Finally, when considering a ferry flight with max fuel weight and 0 payload, our aircraft is capable of flying almost 1,200 miles. The Thin Hull Air Taxi is capable of performing under any conditions in the highlighted yellow region.
The iterative process of constraint sizing resulted in the following set of constraint sizing curves, with a selected point at a power-to-weight ratio of 0.0938 horsepower per pound, a wing loading value of 21.2 pounds per square foot, a total required power of 470 horsepower across 2 engines requiring 235 horsepower each, and a wing area of 236.27 square feet. The figure shows that the stall speed and maximum speed curves are the most constraining, and sensitivity studies show that increasing the maximum lift coefficient would be the main way to lessen these constraints while maintaining the performance. The required power and other relevant criteria resulted in the selection of 2 Lycoming 0540-L3C5D engines for the power plant.
Continuing on, the next slide contains the fully dimensioned views of the finished product with an accompanying legend for clarification. In the left picture, the orange parts detail the fixed equipment, including the avionics at the front of the plane, the life support equipment near the end of the cabin, and the space of the tail of the plane where the empennage is connected to the body of the plane. The red parts depict where the landing gear is located under the fuselage and under each wing, and the dark blue solid blue depicts the flaps on the front and back wings. Next, the people are outlined in green to better contrast the rest of the airplane. Lastly, the right picture shows the front view of the plane. This shows that the people sitting in their seats on the plane have sufficient space to be safely transported during flight.
This slide shows the dimension side view of the aircraft and displays the aircraft's neutral point, indicated at XNP, and center of gravity, indicated at XCG. The gravitational and aerodynamic centers shown here indicate that the aircraft is stable, as the center of gravity remains 4 of the neutral point at all operating conditions. Moreover, the diagrams presented here display the distribution of passengers throughout the aircraft. The craft's capacity is 6 passengers, who will be seated in 3 rows of seats. These rows are 14, 17.5, and 21 feet aft of the nose, while the luggage component of the payload weight is concentrated near the tail of the aircraft, in the storage compartment indicated, accessible through the hallway shown in the top view from the previous slide. Based on data obtained in a report by First in Architecture, the 3-foot 6-inch separation between each chair gives ample legroom to the average passenger, while allowing comfortable, sturdy seats with 6-inch thick backing. Alongside this view is a cross-section of the cabin, with the average male and female passenger sizes according to the same study indicated in red. As shown, the passengers have ample room to sit without being cramped against the curvature of the fuselage, and the aisle meets the FAA requirements of 15 inches minimum in width, allowing for comfortable movement about the cabin.
The long range and faster cruise speed of this aircraft will allow it to have much more mission applicability for long-range remote transport or local-to-hub transport. That being said, the primary shareholders are airlines and the airplane passengers. Since the vehicle is inexpensive to maintain and operate as shown in the table, airlines will be able to use this aircraft for many more missions per gallon of fuel. As a result, the airplane passengers will potentially be able to travel much farther for less cost. The figure shows the comparisons of range and propulsion capabilities and the resulting operating cost for the design aircraft and its competitors. It can be seen that the design aircraft is a good investment for its given range and propulsion capabilities in comparison to the operating cost to achieve them. The thin-haul aircraft will allow face-to-face connection for up to 6 passengers at a long range for this size aircraft, as shown in the payload range curve. Through thorough constraint sizing analysis, 2 Lycoming O540 L3C5D engines were selected to achieve such capabilities and make the aircraft very competitive on the market. The final product features an aircraft that will be comfortable for passengers at a potentially low price.